For over 100 years, quantum tunneling has been one of those wild stories physicists tell each other, like, hey, what if particles could just walk through walls? Turns out they really do, but until now, nobody's really cracked how. Today, I'm about to let you in on the secret, and it starts with a surprise collision that changed everything. Quantum tunneling is nature's ultimate magic trick. Picture this: I take a ball, hurl it at a brick wall, and somehow, poof, the ball appears on the other side, the wall totally untouched. Sounds impossible, right? But if you shrink down to the quantum world, electrons and other tiny particles pull this off like it's no big deal. For decades, we could predict it using math, but the actual how stayed locked away like some cosmic cheat code. Step back to the roaring 1920s. Early quantum legends, Gamow, Schrödinger, were cooking up wild ideas and scribbling mad equations in smoky rooms. They saw tunneling in their numbers, but the mechanism behind it, total mystery. Experiments hinted at something weird, but it was like staring at shadows on the wall. Everyone agreed. Tunneling happened, but nobody knew why. Fast forward to today. The breakthrough comes out of nowhere. A literal collision course. Here's the twist: tunneling isn't just about luck or spooky probabilities. In some ultra-specific quantum conditions, when two particles collide, bam, one gets just the right nudge. It's like cosmic billiards. The collision gives that particle the extra push, just enough to sneak past the barrier. And it's not random, it only works under insanely precise circumstances, almost as if nature's rolling loaded dice. So, why does this matter? Quantum tunneling isn't just a curiosity. It powers the sun, keeps your smartphone running, and could be the key to ultra-fast quantum computers. Understanding the role of these collisions means we might finally tune and control tunneling, opening the door to tech that's still in the realm of science fiction. Imagine quantum computers that don't just guess their way through barriers but punch through with surgical precision. Nuclear fusion, new medicines, even advances in scanning the tiniest parts of our bodies. All suddenly within reach. And here's a fun fact: if you happen to be a subatomic particle, maybe an electron having a wild night, you could technically walk through walls. But unless you've got a quantum collision on your side, I wouldn't recommend trying it at home. Quantum physics just keeps throwing curveballs. 100 years after the first big questions, we're still getting answers that are stranger than science fiction. If you want more mind-blowing science, all in under 5 minutes, smash that subscribe button, and I'll see you on the next discovery.